Oh, sorry, sir. Forget. Good morning, everyone. My name is Nicholas, and today me and my group mates, Geoffrey, Owen, Juliano, and Kevin are going to talk about the group 17 halogens.
The color of the halogens. The color of the halogens tends to get darker going down the group. For fluorine, it becomes pale yellow. For chlorine, it becomes green and yellow. For bromine, the color is orange or brown. And for iodide, it's gray and black solid. It becomes more and more darker down.
Melting point and boiling point increases going down the group. This is because the number of shells increase going down the group, and the van der Waals forces also increase, which increases both the melting and boiling point.
Volatility will decrease down the group as the melting point and boiling point increases going down the group. Because of this, it is more difficult to vaporize.
Reactivity is the tendency of a substance to undergo chemical reaction. Reactivity decreases going down the group. This is due to the increase of number of shells, making there be more shielding effect. As ability to gain electrons is thus due to this, the reactivity will decrease.
Electronegativity. Electronegativity is the ability to attract the bonding pair of electrons. Electronegativity decreases going down the group. This is due to when it goes further down the group, it becomes harder to pull electrons to itself.
Displacement reactions of bromine with sodium iodide to the help of cyclohexane. The colors of halogen molecules in this solution are difficult to identify positively in these displacement reactions. However, the halogens dissolve well in cyclohexane, which is immiscible in water, forming two separate layers. The halogens dissolved in cyclohexane are distinctly different colors.
Discuss about the trend of reactions of halogens and hydrogen going down the group. So when fluorine reacts with hydrogen, it explodes in the cold and dark and forms hydrogen fluoride. When chlorine reacts with hydrogen, it explodes with a flame or in sunlight and forms hydrogen chloride. When bromine reacts with hydrogen, it is a vigorous reaction with burning hydrogen and forms hydrogen bromide. When iodine reacts with hydrogen, it is a very slow reaction when heated strongly and forms some hydrogen iodide. The trend is that they become less reactive down the group.
The thermal stability of hydrogen halides will decrease as the bond length is increased down the group, so the energy required to break the bond will decrease.
One of Lewis' totals for halide ions is to see the color of silver halide precipitate on addition of silver nitrate solution. The second way is the effect of precipitate of adding dilute ammonia solution. And the third way is the effect on precipitate of adding concentrated ammonia solution.
Discuss why reaction with concentrated sulfuric acid cannot be used to prepare hydrogen bromide and hydrogen iodide. The melting point of hydrogen halide decreases going down the group as the bond length are increasing. Even though hydrogen bromide and hydrogen iodide are produced, it will be decomposed by the sulfuric acid.
The reactions involved for question 10 involving concentrated sulfuric acid with sodium salts. NaF plus H2O SO4 or sulfuric acid becomes NaSO4 plus HF gas. NaCl plus H2SO4 becomes NaSO4 plus HCl. NaBr plus H2SO4 becomes NaSO4 plus HBr. Then NaI plus H2SO4 becomes NaSO4 plus HI gas. HBr and HI cannot be collected like this as it will further react with H2SO4 and decompose into their elements.